Alright, today we have topic 1-3, solving quadratic equations. Now, our quadratic equations that we're going to be looking at, if you remember from your previous year, a quadratic equation will have a variable squared. That is what will cause a quadratic equation. And the graph of a quadratic will be either a U shape or an upside down U, or maybe possibly an N shape. But that will be a quadratic equation. We will look at solving for the quadratics and what they define as a solving whenever you're looking to solve a quadratic. Uh, in these instances, we're going to be looking for uh, the x-axis, where it crosses the x-axis, also called zeros, roots, x-intercepts. But that is what we're going to be looking for in this lesson. Alright, if you have a look at your notes, we have a couple of definitions to take care of. First one here is a quadratic equation, defining what a quadratic equation is. It is an equation that when in standard form, that when in standard form is in, and this is their standard form for quadratic equations. Remember what I just said? A quadratic equation will have a variable squared. So in this case, here's the form: ax squared plus bx plus c equals 0. Standard form, we will have it equal to 0. Now, in this, you will see some equations. It might not have this portion of it. It does not have to have a b to the x power. It doesn't have anything to the x power. If our b happened to be 0, well, then we could completely nullify this, and we could have a x squared plus c. Now, if we could take care of this, if you completely remove this and you have bx plus c, well, that's not a quadratic. A quadratic must have a variable squared. Alright, now let's look at our definition for solutions. Solutions, which I've already mentioned over, is solutions are where the graph of the quadratic function, where the graph quadratic function crosses the x-axis, crosses the x-axis. You can have, let's put this right here as a note, you can have 0, 1, or 2 solutions. And this is where we're going to have to check. This is why we check our work, to make sure that we have 2. You might get 2 whenever you first work the problem, but if you do not check to see if they work as a solution, you might only find that there's only one of those that actually works. We can also call these, also called zeros. What else did I say? Roots. And x-intercepts. That's the terminology, and just so that way we can look, let me go ahead and I'll pull this out. Draw up an equation right here. Here's my graph. Excuse the lines. if we have a quadratic equation that comes down in this manner right here, our solutions that we are looking for will be these 2 points. So just so that that way we have this, a quadratic equation is an equation that when in standard form is in an a to the x squared plus b to the x plus c equals 0. It's a big key equals 0 form. And the solutions to which are where the graph of the quadratic function crosses the x-axis. You can have 0, 1, or 2 solutions. Let me add an s to our solutions. 2 solutions. And is also called zeros, roots, or x-intercepts. Now, at an x-intercept, what does your y always equal? 0. Here it is, zeros and roots. This is why we want to set this. Go ahead and grab another color. Just for emphasis, that's why we set this equation to 0, because this right here is what our y is equal to. We will have our x and our y will equal to a 0. That's our x-intercept. Alright, moving on to our examples. In these examples, we're going to work through example 1 and example 3. The rest are for you to do on your own. I will show you, we're going to talk through 2 different methods of solving. The first one, obviously, the easiest, but the second one is also useful. It'll help you know exactly what we're looking to do. So our first example we're going to work, it's tells us to solve 2n minus 4 in parentheses, 3n plus 5 in another set equals to 0. We have it equal to 0, so we're set and ready to go. Our first method, I'm going to drag over here my calculator. So you can get on a calculator to work this. Turn on my calculator. We'll go to y equals, here in the top left, y equals. Now we'll just input our equation. Since it's equal to 0, we're fine with that. I'm going to go ahead, I'm going to put in my parentheses 2x. I'm going to substitute x in for an n. It's a variable. We can replace it with whatever we do so choose. Minus 4, another parentheses, 3x plus 5. Now, we can do this a couple of different ways. I'm going to go down to y2, and I'm going to go ahead and put in a 0. Now I'm going to hit graph. Now, one thing we're going to make sure of every time, we're going to go ahead and zoom. We're going to go to 6. It's our standard view. It should show up just like it did, but in case the graph is larger or smaller, it will show most of our standard points right here. You can also, if you need to, we can go to Window, and we can set our maximum, our minimum, and our scale, which is how many each of our little marks, each of them represent 1. We can set that equal to 5, 10, however many increments you need in order to fit the graph appropriately. Now we're going to look at trying to find what our zeros are, or to solve for this. We're going to second, we're going to calculate. We have zeros and we have intersections. Now, a lot of you might have been taught to go ahead and go down to intersection. Well, this is true. This will work. The only reason this does work, though, is because you have y2. If we go back over here, y2 is set equal to 0. When that's equal to 0, you don't see it on the graph, but there is a line being drawn right there at 0. It's already there on the graph itself, but in reality, there's another line behind it. So that's where our intersect will come in at. And for our intersect, I'm going to move over. I'm following our 0 line. Whenever you're on intersect, you can be anywhere in this area. I am somewhere close. I can get on my other line right here, and I can go back and forth, but I am close to this intersection. So at that point, I can hit enter 3 times. And there's our intersection. Our intersection is going to be x equals to 1.6. I'll go ahead and write this over here. We're going to have a negative 1.66. All right, now let me grab the calculator back up, and let's go find our next one. So second calc, our intersection. And I'm going to move over here. I'm going to let it follow that line. I'm going to jump up here to this one. Get it close to in the area. Remember, right now I'm following that y equals 0 line. Get it close, hit enter 3 times. And our next x value is equal to 2. I'm going to write that down over here, 2. Now, let's also look at this calculator real fast. I'm going to go second, calculate, and it's called a 0. We've had it. That's what we defined it as. In our solution, solutions can be called x-intercepts, roots, or zeros. Well, let's look and see if we can find a 0. Now, on this 0, it says left bound. If you follow this line from left to right, you will go down, and you will come back up. So this is the leftmost side. So I'm going to go ahead and I'm going to add a spot right there. Now I want to go to the right bound of it, so that as you move, we're moving to the right. You've crossed over the boundary. You've crossed over our line. And guess, we're not really looking at guessing. Gives us our other 0 as x equal to 2. So that is another way of solving it on the calculator. Let me move the calculator off right here. I'll come back. We have x is equal to, and x is also equal to 2. So our two solutions for this, whenever you write this down, x equals negative 1.6. That 6 will be repeating, and 2. That is our answer to example 1. All right, next let's look at example 3. Example 3 tells us to solve 2x squared plus x equals 28. Now, before we put this into a calculator, we have to do something to it. We have to set one side equal to 0. It doesn't matter left or right. We can move all of this over here, or the easiest solution would be take this 28 and get it to the other side of the equation. In order to do that, we have a positive over here, so we're going to subtract 28 from both sides. Now, I'm going to go rewrite it over here. That way we can view it. Our calculator is present. We have 2x squared plus x minus 28 is equal to 0. All right, so now we have it set to equal to 0. Let me go over here, grab the calculator, bring it back over here, set it up. I'm going to go to my y equals. I'm going to clear it out. I can leave this y2 equal to 0 because we're going to be setting it equal to 0. But now I'm just going to put in my first initial equation. 2x squared plus x minus 28. And I'm going to go and graph it. I can see both areas that it's going to be crossing. So, second, calculate. And the quick one is our intersection. Get it over here on this line. That way I can get it close. It's somewhere in the area that's close enough. Enter 3 times. We have negative 4. So our x equals a negative 4. And let's see what else our x will equal. Second calc. 5. I'm going to jump onto this line. Into the area, enter 3 times. And x also equals positive 3.5. 0.5. And there it is. Both of those solved fairly quickly using the calculator. Alright, so now we have solved it with the calculator. Now we're going to look at it, working it out and seeing what the calculator is actually finding right here. We can do this without a calculator. Maybe you're somewhere you don't have access to one at the time being, and you get a quadratic equation. They ask you to solve it. Well, instead of just being stuck saying, well, I only know how to use it on a calculator, you can solve these just using good old-fashioned pencil and paper. So we're going to look back at number 3, example 3, and we're going to run through this here fairly quickly. First, we have to do the same thing. We have to set one side equal to 0. So I'm going to go ahead and go through that step of subtracting 28. Subtract 28 will give us 2x squared plus x minus 28 is equal to 0. Now, at this point, we're going to take whatever is with our variable squared, 2, and then we're going to take whatever does not have a variable, 28. We're going to multiply those two numbers together. It will get you negative 56. Take it, draw your little chart just like that. We'll put a little T underneath it. Now we have to find two factors of 56, factor being two things that multiply together, that will add up to a specific number. Whatever number is right here with our lone variable. Now in this case, plus x, that's going to give us a 1. So we're after a positive 1. Two things multiply together to get negative 56 and add up to get positive 1. Well, let's see. You can go through the list of factors. We can look at this and we can say, okay, well, it's 1 and 56. We know from what we've multiplied. 2 and 28, that'll add up to 56. Now, either of these can be negative, but we have a negative 28 plus 2, not going to give us positive 1. Work your way on down here. Work your way on down. You will find two factors of being a 7 and an 8. Now we've got to decide which one should be negative. We have a negative 8 plus 7. That's going to leave us a negative 1. Not going to add up to be a positive 1. So I'm going to put a negative 7 and a positive 8. So I'm going to come over here, rewrite my equation now. I'm going to put my 2x. I'm going to start writing. Squared. Now that I've come to this, we're going to substitute these two things. We're going to substitute those two in for this. We're going to put those two in right here for this. We're going to add an x to it. So let me put this minus 7x. You have a positive 8x minus 28 equals 0. Now that we have this, I want you to cut this in half. We're going to draw a line right down the middle. Now we're going to take each of these and we're going to factor out everything that we can factor out of both of them. So in this case, we have our 2x squared minus 7x. What can you take out of both? Well, you can't take a 2 out of both of them because you can't take a 2 out of 7. By taking it out, I mean dividing by. What can you divide both of these by evenly? Here, in this case, there's an x with both of them. Now here's an x squared. That means if we write this out, it's 2 times x times an x minus a 7 times an x. Our common thing with this are our x's, so we can take that out. Pull it out. Now what are we left with? Put that into parentheses. We're left with a 2 times an x minus a 7. That's all we have over here. Now on this side, if we was to actually factor this out, we could factor this out, and this would be a 2 times a 2 times a 2 times x minus a 7 times a 2 times a 2. So let's look at what we can take. We've got two sets of 2's and two sets of 2's. So let's take both of those out and multiply them together. 2 times 2 is going to give us a 4. So we're going to take out a 4 out of both of these. We're going to have to leave our x because we don't have an x over here. It's going to leave us with a 2x. And over here it's going to leave us with minus 7. Now, if we've done this correctly, what you will see, both sides of our parentheses will have the same thing. We've got a 2x minus 7 over here and a 2x minus 7 over here. So we're getting closer to solving. Let's bring this 2x minus 7. 2x minus 7. Go ahead and bring it down, put it in our parentheses. Now we're going to open up a whole new set of parentheses. Now we're going to put what's on the outside, left or right. Our left side, we've got an x. Let's go ahead and put it in, x. And here we have a positive 4. We're going to set both of those equal to 0. Now, at this point, we're going to take each of these. We're going to take this will be 1 and this will be 2. We'll set 1 and 2 both equal to 0. So we have a 2x minus 7 equals 0. These are our two factors, and then x plus 4 equals 0. So whenever we factor this out, this is what we're going to come up with. If anybody ever tells you to factor a quadratic, this is what you're going to get. These are our factors. Now to solve it using these factors, we're going to set each of these independently equal to 0, and let's see what we come out with. If we remember correctly, our answers are -4 and 3.5. So let's work this out. We're going to have a plus 7, 2x equals 7. Divide both sides by 2. X is equal to 7 over 2 or 3.5. And over here, subtract 4, x equals -4. So our solution, once again, x equals 3.5, and it also equals a -4. Alright, now lastly, let's go back to our example number 1. Example number 1, in this case, makes it very, very easy for us. Going back to what we had before, our answers should come out to -1.6 repeating, where if you have that as a fraction, will be a -5 over 3. And then we have a 2. So let's see if we can get that. Right here, look, they're already worked out. Here's our factors of our quadratic. We don't have to work this out in any shape, form, or fashion. All we have to do is set 2n minus 4 equal to 0 and 3n plus 5 equals 0. Subtract 5, 3n equals -5. Divide both sides. N is equal to -5/3. Alright, so that works out over here. Let's look at this one. Plus 4, 2n equals 4, divide by 2, n equals 2. So there's a quick way to show y'all that you don't have to have a calculator. All you have to do is be able to factor out a quadratic, and you're going to get it in this setup right here. You'll have two factors. You set each of those equal to 0, and then you solve for your variable. And that will get you your solutions, your x-intercepts, your roots, your zeros, whatever term, whatever phrase they're asking for, that will get you the answer. Now, on our next lesson is where we'll have quadratic applications on topic 1.4. That's where we will be looking at some real world problems using quadratics.